of linear.
So we are looking at solution of what? Non-linear homogeneous differential what equation. Okay, now pay attention to something.
Sorry, I want to ask solutions
Okay,
of linear homogeneous
yes,
differential
yes.
equation. Is it linear or non-linear?
No, this is linear. Yeah, you are not solving non-linear or linear. No, all those non-linear, you can't solve that one here. Okay.
All right.
Yeah, just linear. You know we are looking at. Okay, linear in the sense that there's no product of x and y in that term. Like there's nothing like x, y. You understand? Good. And it's non-homogeneous because check. You see, let me tell you what non-homogeneous means now. Look at this example. See, for example, if I give you something like this, y prime prime plus py prime, check this thing, plus q of y equal to, if I say equal to 0, where p and q are function of, it can be function of, let me say, a constant or x. Now, pay attention, a constant, sorry. Now, check something out. Since this guy is equal to 0, we say it is homogeneous. But now it's not equal to 0. It will be equal to like a particular function of x. This one now are non-homogeneous. Like now, we'll be having something here now. That's what we call non-homogeneous. Do you get that? Are we together?
Yes, I understand. Yes.
Good. Yeah, now let's pay attention. You see, the solution to non-homogeneous differential equation always consists of two parts. Now pay attention. The complete solution, are we together?
The solution.
Yeah, the complete solution consists of two parts. And what is what? Y equal to CF plus PI. Just take note of this point, very important. That's it. You see, the complete solution to linear non-homogeneous differential equation consists of two parts. So we have CF. CF is called complementary function. CF is called complementary function. Okay, complementary function. And PI is called what? Particular integral. Particular what?
Integral.
Particular integral. Now pay attention. You see, everything we have been doing before, the previous questions I've solved before this class, the one on homogeneous, everything you have been doing there is complementary function. You have been doing all this before already. Now, what you now want to learn today to now be able to solve non-homogeneous differential equation is particular integral. Exactly. So what you now want to learn now is how to find particular integral. Are we together?
Yes.
Yes. The question we have been solving using that D operator, quadratic equation, complex number, all this stuff, they are method of finding complementary function. Now, you have learned how to find complementary function. The next thing is now what? You are now going to learn how to find particular integral. Now, pay attention. So the method for finding particular integral that you want to learn in today's lesson is method of variation of parameters. Using what?
Method of variation of parameters to find particular integral.
Exactly. Method of variation of parameters. Yeah, this one is to find particular integral. To find particular integral. Exactly. Okay, so pay attention. How do we find pay attention? It's very simple. How do we use method of variation of parameter? Now pay attention. Now let me say after solving, I got my complementary function. Pay attention. I got my complementary function to be equal to, let me say, C1 of C1y1 plus C2y2. You see, pay attention. You see this y1 and y2, they are the solution of your differential equation. Are we together?
Yes.
Hello, are we together?
Yes.
Yeah, pay attention. When you get your complementary function, we have something of C1. Remember that whenever we solve, let me say, when we solve a differential equation, we now get our D operator to be M1 and M2. Remember, we always say C1 exponential M1x plus C2 exponential M2. Remember,
M2x.
Exactly. You see this guy you see here now is your Y1. You see this guy you see here now is your y2. Exactly. So what you get from the, yeah, don't worry, we are going to solve examples to make it very clear.
All right.
Good. Now, after getting your CF, you'll be seeing something like, this y1 and y2 are the solution. That is the solution of the homogeneous part. Don't worry, you understand. That's solution to the homogeneous part. Now, good. Now, when you get this, your CF, you get your y1 and y2. Now, there's something is called row scan. What do we call it?
Row scan.
Row scan, yeah. You see your row scan W is equal to, don't forget, we have learned how to find row scan before. Y1,
Yes.
Y2,
Y2.
Y1 prime, Y2 prime, exactly. Because we are having two solutions, Y1 and Y2, so that's why we are having this. In fact, they will not go beyond this for you. Okay, good. Now, after getting your row scan, what is now the method of finding your particular integral? Now, this is where we are going to. Now, to now find your particular integral, now check Pi is equal to, now check, is minus Y1 integral Y2 of X all over your row scan dx plus Y2 integral Y1 of X all over your row scan dx. You see this X here? Don't worry, I will tell you what this X here means. I'll tell you what this X here means. For example, now let me give you an example. See, let me say I give you an equation to solve. This is the equation. Let me say the equation is y prime prime plus py prime plus qy equal to a function of x. A function of x, or just let's say this is what you have x. That x here is what I'm putting here. Before, what you already know how to solve is if it is equal to 0. That one is simple. But now it is not 0 again. It is now x. Exactly. So that x is what I'm putting there. Now let us pick a question and solve. So when you get a particular integral, then you now put your final answer there. Okay, let's go. Let us pick a question. Let us pick a question. Now check it out. Look at this question. Now. So we have this question. I'm calling. So we have to solve. So we have to solve this differential equation. Y prime prime minus 2y prime plus y equal s cubed exponential x. S cubed exponential x. Now look at what we are having here now. Now pay maximum attention. See what we are having here now. You observe that this equation is non-homogeneous because before our previous lesson, this part should be 0, but now it is not 0 again. So it is non-homogeneous. So how do we solve this question? Now pay attention. First thing we find is what we find the complementary function. Now, so to find our complementary function, CF, don't forget we use D operator. Yeah, let's put this in terms of D operator. What do we have? D squared minus 2D plus 1 plus 1, right? Then we say equal to 0. This is what we do to find our CF. Remember, this have we already solved before. So let's find our CF this way. Let's go. Remember, what you're having here is what? D minus 1.
Sorry, I have a question.
Okay.
I have a question.
Okay.
No, in this case now, this equals to x cubed exponential x. It's not to affect us when we are finding this here.
Yes,
just
yes.
0 straight up.
Yes, exactly. Yes. Exactly, yes. Okay, you see, let me add something here. You see this y1 and y2. They are the solutions of, look at this equation, y prime prime plus py prime plus qy equal to 0. Despite there is x here, we are equating it to 0 to find out y1 and y2. Do you understand now?
Yes,
hello?
yes, I understand.
Exactly, equal to 0. So therefore, what do we have here now? Therefore, we have that what? Okay.
Yes, yes, I understand.
Exactly. Our d is equals to 1 twice. Oh yeah, now I have a question for you. So now this is what you now do. You now say, okay, your CF complementary function is equals to. Now tell us, if we have repeated roots, how do we put our solution? If you have repeated
y is equals to c1, c2.
Now
like
we'll not be saying
bracket.
hello. Pay attention. Now you'll not be saying y equal. You'll be calling it was complementary function. Okay.
Okay. Complementary
Yeah, let's
function
go.
equals
So, yeah.
to C1, like open
Mhm.
bracket C1 plus C2x. Close the bracket, exponential. This will be exponential 1x.
1x exactly. This is your solution exactly. This is your companion. Now, and remember that I can rewrite this thing as I can open the bracket to say C1 exponential x plus C2x exponential x. Do you know that?
Yes, that's correct.
Now from here, don't forget C. Look at what we have here now. C1y1, C2y2. So from here now, what is my y1? What is my y2? Therefore I can say my y1 is equals to exponential x. I mean now, and my y2 is equals to x exponential x. Do you see that?
Yes, that's right.
Nice. So how do we now find particular integral? Before we find particular integral, let's get our Roscian. Okay, the Roscian. Get your Roscian. Remember, I'm following everything I've explained here. Okay, after we get y1 and y2, the next thing is to find our Roscian. So let's get this Roscian first. Okay, so what's the Roscian? Remember, y1, y2, y1, y2. Yeah, let's go. What's my y1? Exponential x. Y2
yes. X exponential x.
Exactly. So now, what is my y1 prime? It's still exponential
x.
And what's my y2 prime? Now, pay attention. You use product rule here. Product rule. See. Hello. Let me say you want to differentiate.
Yes,
check.
coming to you.
You want to differentiate d dx of x. Sorry. Of what? X exponential x. So what do we have? You keep one constant, differentiate the other, plus keep the other one constant, differentiate the first one. Okay?
Yes.
Yeah. So what you have there, your exponential x plus 1. That's what you have. Do you understand?
Yes, I understand.
So you have what? Exponential x plus 1. Exactly. So from here, find the determinant to get your Roscian. So what do we have? This times this will give me what? Exponential 2x plus 1 minus, what do you have here? X exponential
x exponential 2x.
If this and this multiply, exactly. And if you open the bracket, you observe that you'll be having x exponential 2x minus plus exponential x minus s exponential 2x. Because this will multiply this and this. Normal mathematics.
I think there is a mistake because if this multiply this, it should be x exponential 2x plus power 2x.
Yes, yes, yeah, exactly. I put it there. So this and this we cancel out each other. Then your answer is what? Exponential 2x. That is your Roscian. You understand?
Yes.
Nice. So to now find your particular integral, what do we do? Don't forget, our PI is equals to minus y2 integral.
Sorry, I also want to ask something.
Okay.
Sorry, I also want to ask something. Since the Roscian is not equals to 0, then it is linearly independent like that, right?
Yes, exactly. Yes, exactly. Linearly independent. Exactly. You can be asked to show that their solutions are linearly what? Independent. Exactly. That's it. Do you understand?
Yes, I understand.
Good. That's the Roscian theorem. So let's go. So this dx plus y1 integral y2x all over Roscian dx. Now let's go. Now let's now find the particular integral. The particular integral now minus y2. What's my y2? My y2 is what? X exponential x. Then integral y1 is exponential x. And what is my x term? This x term, what does it mean? Do you remember what I said? This big x I'm putting here. Is that function of x that you are seeing?
Yes.
Do you see that?
Yes.
S cubed exponential x. So
sorry, to confirm, the formula for particular integral is minus y2 integral y2
y1
integral y2 integral y1
yeah
over
function
Roscian
Yes, function of x dx.
The other one is now plus y1.
Y1. Yes. Yes.
It's y. Okay.
Yeah, right. So that my x term is s cube exponential x. Yeah, s cube exponential x. Then all over, if you check our Roscan that we got here was exponential 2x dx. Then plus y1 exponential x integral. What's my y2? X
exponential x.
Times my x term is still s cube exponential x. Then all over, my Roscan is exponential 2x. Then I have dx. Now let us go. Let us simplify this. My particular integral is equals. Now check exponential. If you check exponential x twice, we cancel this one below. You get it?
True.
Also exponential x twice, we also cancel this one below. Therefore, we'll be left with, you see, caution, never place what you have here inside the integral. It's not possible to be outside. And never place what you have here inside the integral to be outside, okay?
I get some.
Good. Now let's go. So minus exponential x. Now you'll be left with integral s cubed dx. That's what you have there. Then plus what you have there is exponential x integral. What you have here, s raised to the power 4 x. So what you are now having here is now soft. So what you have here is minus x exponential x. If you integrate this, you have what? S raised to the power 4 all over 4. Then plus exponential x, and what you have is s raised to the power 5 all over what? All over 5. Exactly. So therefore, my particular integral is now equals to what? Minus s raised to the power 5 exponential x all over 4. Then plus what do you have here? S raised to the power 5 all over 5. Then exponential x. Do you get that?
Yes.
Now, you can add these two together. They have common coefficients. You can add them together. Abina, if you add them together, you have 1 over 20, I think. What we have? Just say minus 1 over 4 plus 1 over 5. What do you have? Minus 1 over 4.
Minus 1 over 20.
Okay, exactly. So I'm coming, please. Hold on. Okay. Okay, have you checked ours? There's nothing like sign error, right? Everything is correct that way. Let me see. Yeah. So let me see this minus this minus this. Yeah. So it's correct. Okay. Let's go. All right. So what we have there is what? Minus what?
1 over 20. That would be minus x over 20.
Minus s raised to the power 5 exponential x all over 20. Do you get that?
Yes.
Nice. Okay, do you know that? Do this for me. Minus 1 over 5 plus 1 over 4. What do you have? Minus 1 over 5 plus 1 over 4. What do you have? Okay, that will be. No worry, it's okay.
1 over 20. That will be plus.
Okay, so this is what we have. Therefore, this is our particular integral. Are we together?
Yes.
Now, after getting particular integral, remember our general solution is y equals CF plus PI.
Plus PI.
So exactly. So what's my CF? My CF is what? My complementary function. What did I get? My complementary functions. C1 plus C2x exponential x. Exactly.
Yes.
C1 plus C2x exponential x. That's my complementary function. Then what's my particular integral? Minus what they have s raised to the power 5 exponential x all over 20. This is my complete solution. This is my complete solution. Yeah,
this is nice.
Okay. So is that taking?
Yes, it's taking that.
Next. So that's how to solve question using the what? Using the method of division. But you see, it's the same thing that way. all true. Are we together?
Yes.
Now, another method for finding your particular integral. Okay, for Roskian method, for this method we just solved now, a method of division of parameter, take this as your assignment. Okay. Okay. Take this one and produce it. Okay. Take this as your assignment. Y prime prime plus 2y prime plus y equal exponential minus x all over x. And add this one to it. Y prime prime plus, so I can master it, is equals to sec x. Are you there?
Yes, sir.
Nice. So that's for that. Next one we want to look at is, okay, I've written it. They don't let me claim it. So let's go. The next one we want to look at is, method of, this is another method to find particular integral. There are many methods. There are many. In fact, hello, can you hear me?
Yes, I can hear you.
That D operator that we have been using, it has its own method for finding particular integral. It has, but our lecturer are not considering that actually. But it is also complex. But these are one of the simple, but they have limitations. A method of relation parameter cannot solve all questions. Also, this one I want to talk about now cannot solve all questions. So that's their shortcoming. They cannot solve all questions due to some reasons. Okay. Now let's go. So the next one I want to look at is method of undetermined coefficients. Method of undetermined coefficient. Method of undetermined. From the name, there are some coefficients that we have not determined. Okay, now pay attention. Can you hear me?
Yes, I can hear you.
Yeah, so you see, for this method of undetermined coefficient, there is something we are going to be doing. We are going to be guessing what we call a trial solution. Pay attention. Remember, I was giving you something like y prime prime plus p y prime plus q of y equal to, let me say, a function of x, right?
Yes.
Now we are going to be guessing some particular integral in terms of our guess is based on what is here. Okay, this is a guesswork based on what is here. Now I will give you some rules on how to guess. Now pay attention. Let me call this x terms in x, and let me put this as the guess. That's choice for particular integral, pi. I will explain something to you. Now pay attention. You see, let me say what this x have. Let me say this x now, assuming that it is exponential that is there. Let's assume that, what they give you here now, that term in x now has exponential. Or let me say it has exponential with some, let me say it has some coefficient, like, give me any coefficient. Like
exponential 2x.
Let me say it has some coefficient like c. Let me just say that. Let me see what you have here, like 3 exponential 2x now. So this 3 now, no matter what it has, let me say this is what we have. If that your term in x is exponential with some coefficients, you are going to guess your trial solution as k exponential ax. Don't worry, you are going to solve question on it, you understand. Just take note. This is the first guess. Another guess is this. If you have, these two are very, very important. If you have your term in x to be like c s is to power some power like n, I'll give you example for this, don't worry. You will guess your solution to be like, let me see, kn s is power n plus kn minus 1 s. No, I will give an example. Plus dot 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 up to k1 s is power 1, then up to k0. Let me give you an example. Assume you have something like, let me say, 5 exponential, let me say 5x is to power 3. You are going to say k3 s cubed plus k2 x squared plus k1 x, then plus k0. That's all. All together?
Yes.
Some textbook will use something like as cubed plus bx squared plus cx plus d. No matter the coefficient you use, there's no problem. Shall take note that what the powers are decreasing up to 0. That's it. Do you understand?
Okay, understand.
Yeah. When we solve question. Now, what of if we now have for cos of ax? Let me assume it is for cos that you have, or you have for sine. Let me say these two, you have them. Let me say you have cos and you have for sine, or whether it's only cos you have for sine. What will you do? Both of them have the same thing to do. Let me say you'll be having, let me say k1 cos ax plus k2 sine ax. This will be your guess. Don't worry. Just copy this thing down, then I will solve question on it.
Yes, sir.
Good. Now, let us now solve a question using method of undetermined coefficient. Now, pay attention. Now, see. You have to solve this question. So you have to solve the differential equation. Let's start from simple one. I'll solve 2 questions on this so you understand. Y prime minus y prime. See, take note of this method cannot work for tan or for sec, or for cosec. All these things cannot work. You will know why. Don't worry. You even see the reason when we are solving. Let's go. Minus 2y equal to 4x squared. So let's go. Now, solution. Remember, the first step is to find your complementary function. So the same way. So to find your complementary function, to find CF, what do we do?
Squared
minus d minus 2 equal to 0. I mean,
equals to 0. Yes.
So what do we have here? D minus 2, d plus 1 equal to 0. So therefore, d equal what? 2, and d equals to what? Minus 1. Are we together?
Yes.
Exactly. So as we have this one, so we can just, okay, therefore, our complementary function is equals to c1 exponential 2x plus c2 exponential minus x. I mean, now?
Yes.
Exactly. So this is what you have. All together?
Yes.
Okay. Or wait. For this one, say I'm coming. You can say, well, see it. This one I can decide to say this is my complementary function, but let me denote it as y. Some textbook will say yc complementary, but there's no problem. What I need to denote it, there's no problem. It's my final solution that matters. Let us just continue solving. You will see why I'm doing all this. Are we together?
Yeah.
Nice. See what I have here now. Now, the next thing is that now to find particular integral, this is where the game will change. To find particular integral, remember, what we are using now is method of undetermined coefficient. Now, check. What I'm having here is 4x squared. What will be my trial solution? What will be my trial solution? It will be what? Like ax squared plus bx plus c. Have you now?
Yes.
The coefficient does not matter. Exactly. So therefore, my trial solution is going to be y equal to what? What will I say?
That will be 4x squared. Ax squared plus bx plus c.
Plus c, thank you. Oh, good. Now, okay, well, put this back as CF. I think it does not affect it. Don't problem. Let us put it back as our CF. Now, see what I'm having now. This is my trial solution. Do what I wanted to write. For your trial solution, particular integral, write y equal to what? Depending on what you have here. Are we together? Depending on what you have here.
Yes.
Okay, now I'm putting it this way now. See, pay attention. Remember that in the question they gave us, there's y prime prime. Have you?
Yes.
Also, in the question they gave us, there's y prime, right?
Yes.
Now, come here and find out y prime prime and y prime. Shall we? Let's go, shall we?
Yes, sure.
Yeah, let us differentiate y prime. What's y prime? We have differentiate. What do we have? Differentiate. What do we have? 2ax, Abi?
2ax, yes.
Plus b. Abi now? Nice.
Yes.
Next one, we have y prime prime. We have differentiate again. What do we have? 2a. Abi?
Yes, yes.
Then after you get that, then substitute into the differential equation. Substitute everything you have into the differential equation. Y prime prime minus y prime minus 2y equal 4x squared. Yeah, let's go. Put it there. What's the y prime prime? What do you have?
2a.
2a, nice. Minus, let me show you.
Minus b.
2a minus 2ax plus b minus 2. What is my y? ax squared plus bx plus c. Have you now?
Yes, equals to 4x
squared. Have you now? Yeah,
yes.
Let us open the bracket and yeah, you see that I'm going to open. So open the bracket minus 2ax minus b minus 2ax squared plus, sorry, minus 2b. What do you have here? Okay, I've opened this bracket.
I have
2bx minus 2c equal 4x squared. Have you now?
Yes.
Yeah, now bring all x term, bring all x squared term. So this is my x squared term. Have you now?
Yes, minus 2ax squared.
Then what half x, bring it here, minus 2a, minus 2b,
Minus
x.
2.
Exactly. What half x, bring them together. Have you now?
Yes.
Like what you always do in your partial fraction. Then plus, what do we have here again? Yeah, give me constant. 2a minus b minus 2c, exactly, equal 4x squared. So what will you now do here? You now say, okay, comparing coefficients. Comparing what?
Coefficients.
Coefficient. Now you are comparing coefficients together. You can compare your coefficients. Yeah, let's go. Let's first compare. What do you have here for s squared? Let's compare coefficient of s squares together. What do you have? Minus 2a, Abi?
Minus 2a equals
will be equal to 4. So therefore, a equal to what? Minus 2. Abi now?
Yes.
Good. Next, let's compare for x. Let me say that there's space here. Okay, there's space here. Let's compare. I'll be writing now that in now. Now let's compare for x. What do you have? Do you get? Or I should go to the next page.
Yes.
Next page.
No, I understand. For any
okay. Yeah, coefficient of x. Let's compare. No, let me go to the next page. So yeah, next, let's compare coefficient of x.
Minus 2a.
Let's compare coefficient of x. What do you have?
Minus 2a minus 2b.
Let me see. So we have minus 2a minus 2b equal to what here? Here, there's no
Equals to 0.
Equal to 0. Thank you very much. Minus 2a minus 2b equal to 0. And don't forget, what is my a previously? What did I get as my a?
A is minus 2. Minus 2.
Okay, check. Our a here is what? Minus 2 exactly. So minus 2 minus 2 minus 2b equal to 0. So what do you have here? 4 minus 2b equal to 0. So you have 2b equal to 4, and therefore my b is equal to what? 2. You see that?
Yes.
Exactly. So lastly, let's compare the last term. Let's compare the last 2a minus b minus 2c. Okay. 2a minus b. Is it minus b or minus 2b?
Minus b.
Are you sure? So 2a minus b minus 2c, yeah, equal to 0. So let's go. My a is what? My a is minus 2. My b is 2. So this is minus 4 minus 2 minus 2 is equal to 0. Minus C is equal to C. Therefore, C equals to what? Minus 3. Do you see that?
Minus. Yes.
Now, don't forget. Remember that on my particular integral, I did one thing like the trial solution, which was ax squared plus bx plus c. Have you now? So what will it be here? Can you hear me? Hello, can you hear me?
Yes, I can hear you.
Exactly. Remember, this is my trial solution that I obtained. Oh yeah, I've now gotten a, b, and c. So what's my a now? A is what now? Minus
2x squared
plus 2x minus 3.
plus
Altogether.
2x minus 3.
So my
Yes.
complete solution here is what? Y equal to what? Complementary function plus particular integral. So what's my complementary function? Don't forget, we got C1 exponential 2x.
2x. Yes, C1 exponential 2x plus
2
C2 exponential minus x.
Exactly. Yeah. What now my particular integral? Minus 2x squared. I mean,
plus
2x minus 3. That's our final answer. That's it. Okay. And okay, let me not remember that what I taught you previous year. You see, what you just be doing from now on is to practice so that you will not forget any of these things. You see, let me tell you. See what I taught you here. What of, I want to ask a question. What of if this function of x was not like s cubed, let me say, plus sine x altogether? What will you do? It's simple. Pick the trial solution for this. Add it with this. Let me give you an example. Remember, if it is for x cubed, what do we say? Ax cubed plus bx squared plus cx plus b. Abina. Nice. Now, if it is for sine x, what do we say? We say, don't worry, we say some constants, a cos ax. So what do we now say? We say the same thing. So we say, okay, let me see e. You see that I'm going to write cos x plus f sine x. Do you see that?
Yes.
It's very simple, exactly. That's how we just do it. Exactly. So let me say what is there now is like, let me say, assuming sine 3x now. You say e cos 3x, e sine 3x, and so on like that. So you add it together. But this one do not work for all of them. It do not work for all of them. Yeah. Okay. So that's it. So this is what we are learning actually today. But we just keep solving question. Yeah. So what you will learn in your next class will now be differential equation by reduction of order. I don't want to teach it together with that one, with all this one, so you will not run into trouble. So after that reduction of order, they will not enter Laplace transform. Do you understand?
Yes.
Exactly. So let me just pick another question and solve for you. Okay, let's pick up. Which one should I solve? Is it on method of variation of parameter or method of undetermined coefficient? Which one should I solve on?
Let's do this undetermined coefficients.
Undetermined coefficient, okay? I'm coming. Okay, let's solve the one that has trigonometry. Yeah, I'm coming. Using the method of undetermined coefficient. Then we have to solve sine 2x. Okay. All right. So that's it. Okay. Firstly, what do we find? We find our complementary function, right?
Yes.
Yeah. What do we say? D squared
minus G
minus 2 equals to 0. So we have D minus 2, D plus 1 equal to 0. So therefore, what do we have? D equal to 2 or minus 1? right? So therefore, our complementary function will be equal to C1 exponential 2x plus C2 exponential minus x.
Minus x.
So we have already learned something like this. Now, the next one is that to find particular integral. Exactly. So to find our particular integral. Now, what will now be our trial solution? This trigonometry, I can just pick any coefficient. I can pick K1, K2, or A and B. Which of them should use A and B?
Let's just say I'm right.
Okay, you can say A sine 2x plus B cos 2x. That'll be our trial solution. All together?
Yes.
And we're not going to get y prime. Yeah, let's go. What's our y prime? What's our y prime?
Y prime.
Remember, what you have, if you differentiate sine 2x, it will be 2 cos 2x. Then
Cos 2x. Yes.
Yeah. So I have 2a cos 2x. Then this one what? Remember, for cos, let me remind you.
Minus
2 cos 2x, exactly. Minus 2
sine
2x, exactly. So minus 2b minus 2b sine 2x. So that's my y prime. Next is that you have to find your y prime prime. Let's go. Differentiate this one more time. What do you have? This one is minus 4
4b
sine 2x minus 4b cos 2x. Because the differentiate sign is still have cos. So the minus will not be. Exactly. So therefore, substituting into the above equation. Inside the above differential equation. Now, put it in the above differential equation. That is, here you have y prime prime. So put this y prime prime here. What we have? Minus 4a sine 2x minus 4b cos 2x. Then you have minus y prime. What's my y prime? This. I want to go straight to the point. I'll be having 2a cos 2x.
Yes.
Then plus 2b sine 2x. That minus will change this one to plus. This minus here. Are you there?
Yes.
Next, we have minus 2y. Minus 2y. What's my y? This is my y. Minus 2y. So minus 2 multiply everything you have here. So you're having minus 2a
Minus 2
sine 2x minus 2b cos 2x. Then everything equal sine 2x. Yeah. So what we are having here, check. Bring all sine x together. We'll be having, or bring all sine 2x together. We're having minus 4a plus 2b
sine 2x
minus 2a
plus 2b sine 2x. Yes.
minus 2a sine 2x. Then what again?
Minus 2b sine 2x.
So yeah, bring 4b together. Minus 4b minus 2a
Plus 2
minus 2b cos 2 equal to what? Sine 2x. Check whether this makes sense, whether it's complete. So minus 4a for sine, minus 2 plus 2b, then minus 2a, correct? For cosine, what do you have? Minus 4b, minus 2a,
cosine.
2b, exactly. Yeah, let's go. Now, comparing both sides. Comparing both sides, what do you have? Let's go. What do you have? Minus 6a plus 2b equal to what the coefficient of sine x? 1. Abina?
Yes.
This, exactly. So equal to 1. Also, if you look at this now, check. Look at this one now. This one gives you what? Minus 2a. This one, if you compare the coefficient of sine 2x, you have this. Compare the coefficient of cos 2x, you have this. So minus 2a minus 6b equal to what? 0. Equation what? Equation. Do you have Casio calculator to solve this equation? Or we should solve it. Let's solve it. So let me say I'm multiplying this equation now by let me say I multiply this one by 3, for example. If I multiply this one by 3, what will I have? I have minus what? 18a plus 6 equal to 3. This sum multiplied by 1. What do you have? Minus 2a minus 6b. Abi now?
Yes.
Equal to 0. Oh yeah, add both equations together. What do you get?
Get minus
Add
20a
Mhm.
3.
Equal to what?
Get
3. Exactly. So therefore, a equal what? Minus 3 over 20. All together? So you have gotten that one. Okay, how do we now get b? Remember from equation 2. From equation 2, my b can be equal to, see what I'm having from equation 2 here. Check. So my b can be like I have minus 2a equals 6b. And my b will be equal to minus 1 over 3a. Abi now?
That's
So
correct.
that will be equal to minus 1 over 3 times minus 3 over 20. So this will cancel. I'll have what? 1 over 20. Do you get that?
Yes.
Therefore, can you now tell us what was now a particular integral? What was now a particular integral? Now come to this trial solution here. A sine 2x plus b cos 2x. So a sine 2x plus b cos 2x. Abi now? So these are particular. Remember our complete solution. You see a question. You see a question can just tell you that find a particular integral only. I've seen questions like that very well. Because complementary function is simple, even for secondary school students. So let's go. What's my complementary function? Where did I get a complementary function?
C1 exponential 2x.
C1 exponential 2x and C2 exponential minus x. Have you now? So C1 exponential 2x plus C2 exponential minus x. Have you now? Then plus what's my particular integral? Any one of these can come first, there's no problem. So minus 3 over 20 sine 2x plus 1 over 20 plus 2x. Exactly. So it is as simple as that. Very, very simple. If you can practice it, the two methods are simple. So just go and ruminate this method. Like, go and play with them very well. So let me give you one assignment on this. So it's not like I'm giving you 3 assignments. Have you now?
Yes.
Okay. Let me help you. Okay, things that I'm coming. Let me see. There's something I want to check here. Okay. 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 So your assignment, it should be okay. Look at this. Your assignment on please don't end. This method is what I want to use for this. Okay. Method of undetermined coefficient. D square y over dx square plus dy dx minus 2y equal x plus sine x. So that's what you're using for this. So that's what we are learning for today. Do you have any question? Hope it's clear.
Yes, everything's clear.
Yeah, nice. So I will send the note to you. Let me download it. So no question, Abby? No question, right?
No.
So it's like when you are in class tomorrow, right? So
yes.
that's when we are.
But I think tomorrow is not 3:07.